Okay, my friends, here we go with the wicked awesome packet. It's a beautiful sunny day, and I found $1 in my pocket today. So here we go. All right, this is a simple harmonic question, they call it, where you're on a spring, just keeps going back and forth and back and forth. Let's cover everything. Right here is called the equilibrium position, where there is no stored energy in the spring, because the energy in the spring is given by 1/2 kx squared, and k is the stretch. At this position, there's no stretch, there's no energy. So potential energy here is 0. Therefore, your kinetic energy here of the block going back and forth has to be at its max. That's where it's moving its fastest. Also, there is no force in the spring here. Now, when you're at this position, everything I say for positive A is exactly the same for negative A, just over the other direction over there. Here you're just slowing down and stopping, so your kinetic energy here is at its minimum, actually 0. The potential energy stored in the spring is at its max. The force in the spring is at its max, because X is at its max. A in this case, they call it A instead of X. And if your force is at its max, according to F equals ma, your acceleration is at its max there. So like I said, everything said here is good for here. Okay, so which of the following statements is true? The block has maximum acceleration at A. Well, that's what I just said, so there we go. All right, I look at this, anytime I see a graph, I want to know what the meaning of the slope and the area is. I only know of one place in this physics course where force and time come together, and that is impulse. Impulse is a change in momentum, which is usually due to a change in velocity, which is a force times a time. So if I just looked at this area, and I multiplied force by time, I'm multiplying base times height, I could almost guarantee it's going to be an area question. So for the time interval shown, what is the total change in momentum of the object? Well, I can set this area equal to that change in momentum, and we're done. So your change in momentum is force times time. Let's see, this one, we got, that's a triangle, 1/2 base times height, 10 times 2, that would be 10, half of 20 is 10. This one's going to be 20, and this one's going to be 5. Positive 35, because none of this went below the 0. If it did, I'd have to consider that negative change in momentum and subtract it out of the whole. All right, science fiction story. Oh, this is right into this one. F of gravity equals G m1 m2 over r squared. All right, it's only 9.8 on the Earth. Everywhere else, we got to go into this formula. However, if it was on the Earth, and you put in the mass of the Earth, mass of you, radius of the Earth, you're going to get your 9.8 or 10 for this course. But we're on another planet. The planet is half the radius, so I'm going to half the radius. I'm putting parentheses around it to remind you that you got to square your change here. But the same mass. So if you change this, that's all you changed, you're actually increasing your denominator by a factor of 4. 2 squared is, nope, by a factor of a fourth. 2 squared, 1/2 squared is a fourth. That would be changing a denominator by a quarter, and Logan's going to love this one. When you flip it around, you're actually making this 4 times bigger, so it's 4 times gravity. Rock dropped on the edge of a cliff. Dropped is my little tip-off thing that my initial velocity equals 0, so my kinetic energy there is 0. That's a total of 80 joules, and if it's not moving, then that is totally potential energy. 30 meters below the point of release, the rock has 40. So 30 meters, it lost half its potential. That means it's had half the height it used to be. If the energy lost there, what is the total height of the cliff? Yeah, if you went down 30 meters and lost half of your energy, then the total must have been 60. Thing to watch out for in this is left and right's going on. It's a momentum problem. I see something sticking together or colliding together. So I got to worry about my sign, positive and negative. Piece of clay with a mass m is traveling with an unknown velocity in the positive x. So they're telling me that's got to be positive. That's negative momentum for this big guy. When it collides and sticks to, so it sticks to it, that's a sticky collision. That is an inelastic collision. Big losses of energy. Not that it has anything to do with the problem, but I'm saying it because it came up. Negative x direction. After the collision, they're stuck together, sticky collision, and traveling with a velocity of 1 in the negative x direction. So let's set this up. Momentum before, little m times v prime, we'll call it, his velocity that we're trying to figure out, minus 3mv, that way, has to equal, and when all is said and done, they're stuck together, 4m, and it's going at 1 meter per second, but that way. Well, all the m's cancel out nicely. So you get v prime minus 3v equals negative 4. V prime equals, add this to the side, 3v plus 4 meters per second. There you go. All right, part of an experiment. All right, once again, this is Fg equals G m1 m2 over r squared. So as time goes by, these two things will drift closer and closer together. As they get closer and closer together, r gets small. As r gets small exponentially, the force of gravity grows exponentially. Rolling frictionless table. The sensor that indicates, indicates force and time, just like before. Force and time, change in momentum. You don't know the momentum because you don't know what the initial momentum was. Impulse is just a change in momentum. That's why B is not the answer. Force, time, another impulse one. Getting tired of them. Block is pushed. All right, the mass of the block is 3 kilograms, so I got my mass. Was at rest, V naught equals 0. So I know its initial momentum was 0. At time t, what is the speed of the block at t equals 3 seconds? All right, so let's go into m delta v equals force times time. This area, which is a triangle, is my impulse, is my force times time. So I've got 3 delta v equals 1/2 15 times 3. 15 times 3 is 45. Half of 45, 20. 20 and 2.5. 22.5 equals 3 delta v. So delta v equals, well, it goes into 21 7 times and 1.5 times 7.5. Okay, there is a ball coming in. It hits, momentum has components because it's vector stuff, so as it's going in, it's got a momentum in this direction, and it's got an x component in that direction. On the way out, got an x component in this direction, which is the same, therefore no change, but it has turned around in the y and headed the other way. So you have a vector coming in, you've got the vector going out. This is your final, this is your initial. Your delta is always your final minus initial. Oop, that put a T, I don't know why, initial. So to subtract vectors, all you do is turn the other one around and add it. So I'm going to turn this guy around and add it. That's got to be your answer. 2 skaters of mass 30. Skating. Okay, what's the magnitude of the total momentum of the skaters before they collide? All right, you would be suckered to thinking I've just got to say, all right, momentum is mass times velocity. This is 60. 80 times 1, well, that's 80. Add them together, you get 140, but you'd be wrong because they're vectors, so you have to add them vectorially. If this is 60 and this is 80, there is a version of a 3, 4, 5 triangle, my friends. That's how you add vectors. All right, this thing has weight, therefore it's held up by 2 points. 100 down, it's a static equilibrium problem. There's got to be 100 up, dead center, each one gets 50. That means you have a triangle over here where this side is 50, alternate interiors. There's my 30. I want to know this, I want to know what force is in this part of it. So you'd have cosine here because that's adjacent, so cos of 30 equals adjacent over hypotenuse. That would be 50 over your unknown. So your unknown is going to be 50 over cos 30. Oh my, where do we get this information? Hold on. The handy dandy reference sheet. Cos 30, square root of 3 over 2. Replace that with 50 square root of 3 over 2. And when you rationalize, you get 100. There we go. This one's different because this thing does not have weight. All right, all the weight's right here. Therefore, all of it's supported by this guy. So that was 10, that's 100. So your answer is going to be twice what it was here. Because this is still 30.